Scientific notation. It should come as no surprise that many sciences deal with numbers that are either very big, such as the average distance between the Earth and the Sun, or numbers that are very small, such as the wavelength of a certain spectral line of a hydrogen atom. Anytime numbers are really big or really small, it is much easier to write them in scientific notation. Scientific notation is a kind of shorthand that is not only easier to read, but also helps reduce errors in calculations that might happen if every time you had to count all those decimal places, many of which are just zeros. As a matter of fact, when you convert a number to scientific notation, that is exactly what you do. Count the decimal places once and record your count as an exponent on a power of 10. Let's go back to our example of the really big number, 149,600,000,000,000. It can be difficult to tell for sure if you are looking at the average distance between the Earth and the Sun because of all the zeros. Scientific notation allows you to write the number in a more recognizable way and avoid having to count zeros each time. To show you more clearly just how this works, let's convert this number one step at a time. Since scientific notation involves multiplying a number by a power of 10, that's the way we'll proceed. To get started, multiply by 10 to the 0, which is just 1, so doesn't change the number. With each step, we will factor out a single power of 10 from the original number and include that 10 with the power of 10. So when we factor out one power of 10 from the original number, we get 10 to the first power. Take out another factor of 10, and that makes 10 times 10, or 10 squared. Another factor of 10 makes it 10 cubed. Each time, the really big number is getting smaller, but it is multiplied by a factor of 10 that is getting bigger. If you keep going until you have a number less than 10, but still greater than 1, times a power of 10, then you have just converted the number to scientific notation. So, 149,600,000,000,000 equals 1.496 times 10 to the 11th. And yes, you can just count how many places you shift the decimal to get your exponent on the power of 10. As long as you end up with a number between 1 and 10 times a power of 10, you have a number in scientific notation.